Good afternoon, everyone. I am Khalid Al-FARARNI, a PhD student at Sidi Mohammed bin Abdullah University of Fez, and I have the immense pleasure of contributing to this conference by this presentation entitled Item-Based Collaborative Tourism Recommender System using Apache Mahout. Throughout this presentation, we'll start by introducing tourism recommender systems, focusing particularly on the item-based collaborative filtering ones. Then, we'll overview some recent related works. Next, we'll take a closer look at the proposed architecture and present the data flow. Finally, we'll discuss the results and conclude by addressing future directions. A recommender system is a software algorithm that analyzes user preferences, past behaviors, or other relevant data to generate personalized recommendations for items, products, or contents. These systems are commonly used in various domains such as e-commerce, entertainment, and tourism to help users discover items they may be interested in. In the tourism industry, a tourism recommender system can be defined as a digital tool that suggests personalized travel experiences, such as attractions, accommodations, and activities based on user preferences and behavior. It aims to enhance the travel planning process by offering tailored recommendations that match the user interests, ultimately improving their overall tourism experience. In this work, we chose item-based collaborative filtering from the Apache Mahout library to implement our tourism recommender system. Item-based collaborative filtering is one kind of recommendation method which looks for similar items based on the items users have already liked or positively interacted with. It was developed by Amazon in 1998 and plays a great role in Amazon's success. It relies on the assumption that two items are considered similar if they tend to be liked or disliked by the same users. Since a key benefit of the collaborative filtering approach is that it does not rely on analyzing the content of items. It is capable of accurately recommending complex items like tourist destinations without understanding the item itself. Mahout is frequently used in research to create scalable tourism recommender systems. However, there is still space for progress in this domain. In the first paper, an item-based collaborative filtering algorithm is implemented on Hadoop using Apache Mahout to generate appropriate recommendations. Authors apply different similarity correlations and nearest to get a better performance of their recommendation system. Authors in the second paper proposed an online application that uses the item-based collaborative filtering method to generate a personalized list of preference attractions for the tourist based on the visiting history of attractions. In the third contribution, authors combine item-based collaborative filtering with demographics-based collaborative filtering in a hybrid-weighted approach to predict recommendation. The proposed solution addresses the user cold start problem and shows scalable results. To generate recommendations for a tourist, the system will collect user interactions and store them in a database following Mahout data structure. One way to do this is to log tourist preferences to CSV files that contains user ID, item ID, preference. These interactions will then be cleaned up and standardized and will form part of the query of recommendations. Mahout Spark Item Similarity will create a table of item ID, list of similar items in CSV form. Think of this as an item collection with one field containing the item IDs of similar items. When an application needs recommendation for a specific tourist, get the latest history of his visit from the database and query the indicator matrix with this history. The tourist will get back an ordered list of item IDs. This will be his recommendations. As an evaluation method, we hide 20% of our dataset and we try to predict the accurate values. The metric of evaluation used is RMSE. Result shows that the used technique provides suggestion with a low RMSE value and that 92% often correspond to tourist preferences. As conclusion, the aim of this study was to verify the effectiveness of using Mahout to implement a NITM-based collaborative filtering system in the tourism industry, and to study its performance in predicting accurate recommendations based on past visitors' preferences in the area of Darata fields. Item-based collaborative filtering does not need to process each item's content. It's one of the finest algorithms for suggestion of tourist products. The Apache Mahout library was effective for our study because it provides suggestions that most often correspond to tourist preferences. Thank you for your attention.